All right, welcome to 6.3, Interpreting Graphs. So really this is all about graphing. There's really two or three types of problems you're going to see. The main two types are going to be straight lines like we've been dealing with, and really you're just going to be looking at what the x-intercept or what the x-axis represents, in this case time, and what the y-axis represents. In this case it says distance from Grenoble, okay? And then the second type of graph that we'll get to later in the second video will be a curved line. And that you're not going to be dealing with specific numbers, you're just going to be interpreting what's happening. In other words, it's going up, it's going down, it's slowing down, it's speeding up. Okay? So let's go through this problem. It's really about basically reading numbers, finding the slope, and just understanding what the situation is. Okay, this one says the graph shows a return journey by car from Grenoble to Sisteron. And I'm sorry if I'm completely mispronouncing those two places. Okay, so in other words, they started in Grenoble, as you can see, it's distance from Grenoble on the left. Okay, I'm going to make this graph a lot bigger, okay? And I'm going to make this problem over here in the corner smaller. All right? So it says distance from Grenoble, and we start at 0. In other words, we're in Grenoble. Okay? And then we slowly go away from Grenoble, and here we're now 40 kilometers away from Grenoble. And then we stay 40 kilometers away. In other words, we don't travel. We don't go any further. Okay? Then all of a sudden, we drive away from Grenoble again. Okay, and we arrive in Sisteron. You can see Sisteron is here at 100. And they stay there for whatever one square represents, and we'll figure that out in a minute. Okay, and then we turn around and we drive all the way back home to Grenoble. Okay, where again the distance away from home is 0 on this bottom line. All right, so let's look at the questions and see what it says. Okay, so first, how far is it? This is A. How far is it from Grenoble to Gap? Okay, and it says Gap is right here at 40. In other words, from 0 down here at the bottom up to where we stopped the first time at 40, drove 40 kilometers. And that's this place Gap. Okay, so A, it's 40 kilometers. All right, B is how far is it from Gap to Sisteron? In other words, how far did we travel the second leg from here in Gap up to Sisteron? Okay, and all that matters is the distance. So in other words, the y-axis. Well, we start at 40 and we went up to 100. So we went up a total of 60. Okay, so 60 kilometers. All right, C says, at which two places does the car stop? All right, well, it stops in Gap, and you can tell a stop here by a flat line. Okay, 2 squares passed, and in this case, the square is 1, 2, 3, 4 squares represent an hour. So an hour divided by 4. That means each of these little squares here on the bottom represents 15 minutes. Okay, so C says at which two places does it stop? Here it stops for a half an hour in Gap, and then it stops for 1 square or 15 minutes in Sisteron. So for C, you just say, oh, it stopped in Gap and Sisteron. Okay, so you just write the names down. It stopped in Gap and in Sisteron. Okay, so this is really about just understanding the situation here that this picture is telling you about. Okay, D says, how long does it stop in Sisteron? That's this stop right here. Okay, how long was it flat for? How long did they not move up? They didn't move down. Stayed exactly the same 100 kilometers away. Okay, and that's 1 square, or, and we can see again from 12 to 1, it was 1, 2, 3, 4 squares. So an hour divided by 4 is 15 minutes. Okay, so we stay for 15 minutes there. All right, and then E says, when does the car arrive in Gap? Okay, so I'm going to go to a separate page now and just put this back up so we can start E, just because this is getting a little messy. Okay, So E says, when does the car arrive in Gap? Well, we can look, okay? We're driving, boom, we arrive in Gap right here at this point. Okay, I mean, we stay in Gap for 1, 2 squares or 30 minutes, but when did we arrive is right here at this point at 11 o'clock. Okay, so E, the first part of it, I, is 11 o'clock. Okay, and then I, Roman numerals for 2, right, is when did you arrive in, or when did you arrive back in Grenoble? Okay, remember Grenoble is where we started. This is distance from Grenoble. So this is saying we go all the way through our journey, we're in Gap, hanging out, drive further, we get to Cisteron, hanging out, then we drive all the way home, and we get to Grenoble back here when we're 0 distance away from Grenoble. So when did we arrive back at our home in Grenoble is right here, and that's at 1, 2, 3 squares after 1300. So that's going to be 1345 because you're 3/4 of the way. Okay, so 1345. All right, now F says, I'm going to do F in blue. Okay, and this is the tricky one. It's basically just saying the slope. It's saying what is the speed of the car at 3 different sections, right? And obviously, if it was asking what's the speed of the car while you were sitting still at Gap or Cisteron, the speed would be 0. Okay, but it's saying what's the speed from Grenoble to Gap? So starting here and going to here, this first section, it's going to be, and let's see, we went up 40 kilometers. We're just finding the rise over the run. This is part I here. Okay, 40 kilometers and over 1 hour. Okay, so that's 40 kilometers per hour, right? No trick there. Okay, for I, it's saying what's the speed from Gap to Cisteron? So from Gap to Cisteron here, the second leg of the trip, we went from 40 to 100, so we went up 60 kilometers, and we went over from here to here, went from 1130, and we went over 1, 2, 3, 4 squares to 1230. So again, 1 hour. So in this case, we went 60 kilometers, and we did it in 1 hour. All right, so this is equal to 60 kilometers per hour. Again, we're just finding the rise over the run here. All right, and then the third one is from Cisteron to Grenoble. In other words, if we start here at this point where we started moving, okay, we go all the way down till we finish. All right, so in that case, we traveled down 100. The negatives and positives don't matter here because we're talking about speed. Okay, so we went 100 kilometers. And then we're dividing this by, and let's see, we're going to go from here at 12:45, and we're going to go over until we arrive home at 1:45. So again, they made this so easy on us. Each time it was dividing by 1 hour. It would have been a lot harder if it was half of an hour, or 3/4 of an hour, or 1 3/4. But they made it super easy on us. So it's 100 kilometers per hour, right? We're done. So really, you're looking at this scenario where this car speeds up. And now the steeper the line, the faster you're going, because the more distance you're covering in a shorter X or shorter time. Okay? And then the flatter it is, the slower you're going, especially in these 2 areas here where it's completely flat, which means you're not going anywhere. Right? And so the flatter it is, the slower you're going. And the steeper it is, here you're going 100 kilometers per hour. And then pretty steep, 60, and then not as steep, 40. And then something like 20 would look like that, 10, 0, etc. Okay? Let's do one more problem, or a part of a problem. Okay. Here's a similar problem, just a different type of question. Again, you've got a graph, it's all set up for you, it's labeled, and it just asks you a couple questions about what's going on. Okay, this one tells you right clearly at the beginning, this graph shows how to convert miles into kilometers. You got kilometers over here on your y-axis, and you got miles over here on your x-axis. Okay. Now, 1 mile, you can see from the graph, is going to be about roughly 1.5 kilometers, because as we get, just taking a big point, so it's easy to see here, at 50 miles is equal to, as we go up here, about 80 kilometers, which is about 1.5, 1.6. Okay, somewhere around there. So let's look at some of these questions. How many kilometers is 1 small square worth? Oh, well, that's easy. Over there on the left, you've got 5 squares taking you from 0 to 10. And so divide 10 by 5, and you get, oh, each one's 2 kilometers, right? That's easy. Use the graph to find how many kilometers are the same as 25 miles, okay? So let's check. And these aren't going to be perfect. I mean, there's decimal answers for these and stuff, but we're just going to estimate. Okay, here's 25, halfway between 20 and 30. And so we go up and up and up, and bam, we hit our line. So 25 miles is about, boom, 40 kilometers. Okay? And then let's just look at one of the questions in C, just picking one randomly, okay, about, let's pick this one. Okay? Use the graph to say how many miles are the same as 16 kilometers. Okay, so let's look. 16 kilometers is right here, this third square, because remember each square is worth 2. Okay, so we follow that line, and bam, that's where it hits. That's at, 10 miles. Okay, so the answer for this one is 10, and the units are important, miles. Okay, the answer to this one, the units are important, was 40 kilometers. All right. Now, the one other type of question they're gonna ask on the homework is just, what if we tell you the story, we give you the information, we give you the numbers, can you make the graph? In math, it's always important to be able to go forwards and to go backwards. So if they give you the graph, you should be able to tell the story, read the information. Okay, and this is a useful skill in science and business. Whatever job you go into, you're likely going to see a chart, or just even reading the news about the economy or anything. I mean, you're going to see charts. And so it's very useful to be able to interpret that. Okay? And then the other side is, what if your boss says, here's the data? Make a chart and show it to the rest of the company. Okay? Again, super useful skill. All right, so let's look at one of those. Okay, so here's number 6, where it asks you to make a graph. The instructions say to keep the same scale as number 5, meaning each of the squares is worth the same. Okay, so what we can do is check out number 5. I'll let you do that on your own, but it says that each of the squares on the left is worth 5 kilometers. So here's 10 kilometers, here's 20. You'll have to excuse my writing because I'm trying to do this on an iPad. Okay, there's 30, 40, 50, 60. Okay? All right. And then to the right, it goes, and this starts at 0, obviously. Okay, to the right, it goes by 15-minute intervals. In other words, every 4 squares is an hour. Now it says Mrs. Chuang leaves home at 8. So this first one, we're going to do 8 a.m. Okay, and then 1, 2, 3, 4. Here's 9. Then 1, 2, 3, 4. Here's 10. And then 1, 2, 3, 4. Here's 11. All right. And I think we're going to be about 1 square short here, but I couldn't find a bigger graph on it when I searched. Okay, so let's start. It says Mrs. Chung leaves home at 8 o'clock and drives at a speed of 50 kilometers per hour for half an hour. All right, so that means the slope here that she's going to be doing is 50 over 1. In other words, she's going to go up 50 and over 1, except it says we're not going over 1 hour. It says we're going over half an hour. In other words, we're going to go up a half, or 25, and we're going to go over a half an hour. Okay? So here we go. We go over a half an hour and up 25. And so here's our first line. Okay? And obviously you should use a ruler and make it slightly better than mine. Alright, this is okay. So now we're at 8:30. Okay, and we can see that it says after a half hour. Right? Okay, so she reduces her speed to 40 kilometers an hour and continues at this speed until 9:30. So from 8:30 to 9:30, she went an hour. So she's going to go at a slope of 40 kilometers, rise 40, and over 1 hour. And since we went from 8:30 to 9:30, she did actually go an hour. So we are going to go up 40 and over 1. Okay, so starting here at 25, we're going to go up to 65, which I was right, we're going to go 1 too high, and we're going to go over to 9:30. So going up to 9:30, here is, as I say, never to do, never go off your graph. Here is where we go. Okay, so now you can see the line went from a little steeper at 50 kilometers per hour in red to a little less steep in blue at 40 kilometers per hour. Okay, it says she stops from 9:30 until 10. In other words, we've got a straight from 9:30 to 10, okay, because she doesn't move, so her speed is 0. She stopped, and then she returns home at a speed of 60 kilometers per hour. In other words, she's going to go rise 60 and over 1 hour. Okay, so let's do that. Okay, I'm going to go switch back to red here. So we're going to go down from 65, we're going to go down 60, so we're at 5, and over 1 hour. So right here, and so, and then it says estimate, she returns home, so we're going to keep going, and bam, it's going to hit somewhere right around here. Okay, and so it says use a graph to find the approximate time at which she arrives home. So it would be sometime slightly after 11. Okay, and I think if you figured it out, it's like 5 minutes after 11. Okay, and so the answer to this problem would, one part, be this correctly drawn graph, and then the second part, the answer would be where did we arrive home, or at what time, I mean, and that would be at around, let's say, 11:05, 11:10. Okay, and that's your two-part answer. Half being the graph, and half being the answer to the question. Okay, and so you're going to be asked questions like both of these. You're going to be given a graph, and it's going to say, hey, interpret. Look at this. It's going up at this speed, going over at this speed. How long were they stopped? How far is it from this place to that place? And then the second type of question is going to say, hey, here's a little story about little Miss Chuang. She went to the store, she visited her aunt, and then she drove home. And then you're supposed to make the graph of her journey. Okay, and my colorful little graph here that goes off is my answer. All right, well, good luck, and I hope you guys enjoy your substitute teachers.